So we're going to finish our unit today. We did talk last couple of classes actually about quadrilaterals, their properties, parallelograms, how to prove a rectangle, how to do it on a coordinate plane. We've actually done a lot. And then the last part of our unit is talking about polygons. Now, the first bullet point up here, I don't want to have to do because I think you already know their names. I'm going to say things and you tell me how many sides it has. Octagon, hexagon, heptagon, 7. By the way, 7s have 2. Heptagon and septagon. They mean the same thing. Weird, 2 names, same thing. How about, I'm not opposed. How about quadrilateral? 4. How about pentagon? 5 is penta. Listen for the next one. Decagon. How about this one? Dodecagon. 12. Good. So you know their names, is my point, right? You know the names. Huh? 20 is 20gon. There's only certain ones that have special names. Yeah, it would be called a 20gon. Yeah. What's 9? Nonagon. Very good. Yep. All right. Just 10. A decagon. 10 is deca. All right. So we're going to skip naming them because, like I said, I think you already know their names. Okay? If you don't, we'll continue to use them. But you don't want to write this down right now. You're going to write down 4 formulas today. Unfortunately, those formulas are not on the SOL formula sheet. Okay? I didn't pick what went on there. But I'm going to show you how to find them anyway. Okay? So just watch the next little part. We're going to be using this activity that we're about to look at here to be able to develop one of our formulas. Okay? Today we're going to spend time talking about all the angles on the inside of these polygons. They're called interior angles. We also are going to talk about angles if we extend it on the outside. Okay? So we have inside angles and outside angles, interior and exterior. Let's start with the inside angles, the interior ones. Okay? And I want to talk about all of them added together, the sum of all the angles. And I know in a triangle what they add to be, don't I? What is it? All right, so that's a no-brainer. We've been dealing with triangles since what? November, right? I'm done with triangles. 180 degrees, we know that. As the polygon gets bigger, or as you get more sides, it's not as easy to know. You can't memorize that. But I can tell you how to find it. You're just going to divide them into triangles. If I just draw from corner to corner, how many triangles do I have here? So I have both of them as 180 because I know that's what a triangle is. I have 2 triangles each that are 180. What is 2 times 180? Okay, so the total in any quadrilateral is 360. The pattern continues. If I'm going to take one vertex and draw diagonals, how many triangles did I divide the pentagon into? So I have 3 triangles, each at 180. What's 3 times 180? You don't have to write this down, by the way. Just watch. When we get to the formulas, I'll tell you to write it down. You have calculators. What's 3 times 180?
540.
Good. All right, I agree. Looking at a hexagon. If I take one vertex and I draw all the triangles in, how many triangles do I have? I have 4 triangles, each at 180. What's 4 times 180? 720. So all of the interior angles added together, the sum of the interior angles in a hexagon is 720. Well, there's a formula for it, and this is really a derivation of that formula. How many sides does a triangle have? 3. Okay, and we had 1 triangle at 180. How many sides here? 4. How many sides here? And how many sides here? Okay. So I'm challenging you to look at the relationship between the number of sides and the number of triangles. Number of sides, number of triangles. Number of sides, number of triangles. What do you notice? It's 2 less every time, right? Every time. So if I told you in a 24gon, how many triangles could I divide it up into? 22. Could you tell me how many the angles all added up to be? Because the formula, which is these are the formulas you must write down, by the way. The formula is the angles in a triangle, the number of sides minus 2. So we're going to call the number of sides n. Okay, so the number of sides in any polygon minus 2 tells me how many triangles I have, and then I multiply it times 180 because I know that's what a triangle is, what the sum of those angles is. Okay? That's the formula. Just the number of triangles, which is the sides minus 2, times 180. Interior sum. Okay. So let's look at an example of an interior sum. So here's example 1. We're going to do 3 examples today. So I'm going to let you guys copy this example down. And it goes with our interior sum formula. Let's go ahead and label the angle we're looking for as x. Okay? It says to find angle G. So I'm just going to label it with an x. I know in any polygon at all, I have a formula for all of the inside angles added together. And that formula is this. Right? We just went over it. What's n in our case? Well, what is it in this case? It's 4, right? The number of sides is 4. So let's go ahead and plug a 4 in. And don't I get 360? Okay. So that tells me that all of the inside angles, all the interior angles added together should equal 360. Let's write the equation. Okay, fine, Mr. Showoff. Yes. The algebra is going to get more difficult. So I know you can probably do this in your head, but write the equation. All right? So the equation is this. All of the angles added together should equal the sum. Huh? Hewlett got transferred into this class for my 4th period. Wave to everybody else, Hewlett. Say hi. All right. Any questions about where the equation came from? Are we good? Equation's good? All of the insides added together. The problems you're going to have to do today and turn in, the algebra will be a little bit more difficult. I realize some of us can do this one in our head. Not all of us, but some of us can. It's important to know if I have other stuff in here, what I do is I just combine like terms. Okay? These all happen to be like terms. Do you agree? I can combine them. Sometimes I have more x's. I combine the x's. So it's just an algebra. What do these add together to be? 2 something. What? 2 what? 258. I'm still trying to solve for x, right? Then I subtract 258. That's right. So 102 is the missing angle. 102 degrees. Okay? Again, this one's a little basic. I get that. The algebra will get more difficult. Shh. Go ahead, Liba. As long as it's 4 sides, It's 360. If this was 5 sides, it wouldn't be 360 anymore. You'd have to put a 5 in here. Okay? So whatever you set it equal to changes depending on the number of sides. Good question. Michelle? I just subtracted 258 from both sides? This? That's a degree sign? Okay. Yeah. My handwriting can be kind of sloppy. All right. How do we feel? Interior angle sum. We're doing okay. All right. So my next question is, what's an exterior angle? All right. It's an outside angle. Right here. Exterior angle, outside. This angle right here. Outside. Exterior. Not yet. I'll tell you what we're going to do. Because on the formula sheet that we're looking at, maybe, where'd the formulas go? Hang on. There we go. Now I'm looking for the exterior sum. All right? So what I mean is this. If I were to draw all of the exterior angles, what would all these add up to be? Okay, I hear a whole bunch of different things. I have a little video, a little applet that because I'm a math nerd, this is what I do on Twitter, and that's all right. But look at this little applet for me. This is going to be a little video. It has some random polygon, this 5-sided. Look at what happens to all the outside angles. You watching? I'm watching. Watch and see what it happens. Let me try it one more time. All the outside angles, if I bring them in, it's a nice little visual, they add to be 360. So Sanaya's intuition was right to begin with. Okay? They do add to be 360. No matter how many sides there are, always 360. There's no formula. It's just, do you know it? So exterior sum, no matter what, is 360. I can have 327 sides. The exterior sum will still be 360. Okay. When we're getting to one angle, now we're changing the question. Okay? We're going to be dividing. Yes. Any questions about these two? These are sum formulas. Important. So when you are asked to find a sum, this is what you would do. Okay? Any questions? All right, if you look at the ones underneath here, I see a key word. Regular. What does that mean? Okay, let's not use, okay, so what do you mean by normal? What's a regular polygon? This one on the board, by the way, is regular. Let me show you one that's not. These are both pentagons, by the way.
They all have the same size.
Same what? Angles and sides. A regular polygons, all of the angles are the same, and all of the sides are the same. Not yet. Okay? So if we're trying to, on our formula sheet, look at, hang on, I'm getting to the formulas. Here we go. Formulas. We want to find the exterior angle of a polygon. We want to find one exterior angle. Cameron, what was your intuition about that? So if I take all the exterior angles, which is 360, and I divide by what? How many there are. So what would that be in terms of my variable? N. Because there are 5 angles in a polygon, or a pentagon. There are 6 angles in a hexagon. There are 8 angles in an octagon. It's just simply that. Any questions about that? Good? I have a star there for a reason. The star is there because you need to start there. Because sometimes it asks you to find both an exterior angle and an interior angle. All right, so if it asks you to find both, I want you to find the outside one first. What are you doing? What are you doing? Mike, stop. Thank you. Let me show you why. What's the relationship between the exterior angle and the interior angle? Why, Liba? They're a linear pair. Aren't they supplementary? Don't they add to be 180? So if I find the outside one, then I can just find the inside one by subtracting from 180. Slight work. I love it. All right, so here's the formula. Maybe losing my direction here. There we go. If I figure out what my exterior angle is, and I subtract it from 180, that will give me an interior one. Okay? There is another formula that can be used for that. I happen to think this one's easier. This is my opinion. But if you start with the exterior, you find it, find that number, and just subtract it from 180, it becomes pretty quick. Okay? I'm going to show you the other example. Don't write this one down, but I'm going to show you the other formula. Why does that one work too? Don't yell it out. Think about it for a minute. Why does the other one also work? Omar? It's the interior sum on the top. So it's the same thing. Just dividing it by the number of sides. Okay? So they both work, but I think the one that I wrote first is probably the one to deal with. It's less thing to memorize. So let's do an example. Again, I don't want you to do that. Let's try this. Example 2. We're going to do 3 total. Okay? I'm going to highlight the word regular. That's important. Because that tells me I can use those last 2 formulas. If it's not regular, I can't find one angle. Because they're not all the same. So it says I want to find both an interior and an exterior. According to the formula sheet, which one did I tell you we should start with? The outside, exterior. So I started. All right, so if you look at the formula sheet, I starred this one because I want you to start there. Okay, start with the exterior. So I'm going to draw the exterior angle. We're also going to find the interiors. We're going to do both. Right? How do I find one exterior angle? You had the formula written down somewhere on your paper. What's the formula for one exterior angle? 360. So how many sides do we have? In this case, in a hexagon, we have 6. So it's 60 degrees. I agree. Good. I'm going to even write it up in my picture. The exterior angle is 60. Good. Now find the inside angle. One interior. What did we do? We took whatever we just found and subtracted it from 180. Yeah. They're a linear pair. So the inside angle is 120. That makes sense in the picture, doesn't it? Didn't make a line. That's good. All right. How do we feel? Not too bad, right? Inside and outside angles in a polygon. Just you look at your formulas. Figure out how many sides we have, and start with exteriors if you have to. That's basically the deal. All right, so we have one more example. Here we go. Example. This problem, I don't know how many sides there are. It's hidden under a piece of paper or under something. I don't know N. I gotta find it. I have to find N. All right, well, what do I have? I don't have a triangle. I have an angle, though. And what kind of angle? Inside or outside? So I have an interior angle. What did I tell you to start with? Exterior. So let's find an exterior. Let's go ahead and just draw it. Let's find the outside angle. What is it? Which is what? That's right. 72. Perfect. Good. Why do I want the exterior angle? Because do I have a formula that's easy to work with for exterior angles? 360 divided by the number of sides that I don't know. Do you agree? So what does that equal? In my picture, what's the exterior angle? And I'm just going to solve it. Make sure before we get to solving it, you understand where the equation came from. Javier, you understand where the equation came from? Well, let's talk about it. Do you understand where this part comes from? Because it's outside angle, right? If you come over here in the picture, isn't 72 on the outside of the angle? That's why it equals 72. Not 72. You're on the right track about something like this, multiplying by something though. So hang on, this reminds me of those trig problems where the x was on the bottom.
Yeah.
Kind of weird, right? So if you remember, we multiply by n, cancels the fraction. I'm still trying to get n by itself, so I'm going to divide by 72. So what's kind of a shape? What's the polygon underneath there? A pentagon. Because there are 5 sides. And since I have a smart board, I can check it and say, oh, I was right, it's a pentagon. But you're not going to have that luxury. 360 divided by 72. Okay? All right, so let's look at what I'm asking you to do next.